Dear Chair, dear audience, welcome to the 6-month progress report. Well, I'd like to talk about my PhD, which is targeted neuroprotection for post-cardiac arrest patients. My name is Krisztina Csőke-Kabai. I work at the emergency department at the University of Szeged. I'm also a first-year PhD student. My vision is that all resuscitated patients should thrive and not just survive, and my mission is to drive therapeutic innovations for better quality of life following resuscitation. To reach these goals, we've launched 2 projects last year, both of them about the neuroprotection of resuscitated patients. Let me start with my first project, which is investigating the efficacy and safety of pre-hospital targeted temperature management on neurological outcome in out-of-hospital cardiac arrest patients. So the problem is that out-of-hospital cardiac arrest happens about 1 in every 1,000 people just alone in the United States. 50% of these patients receive resuscitation, 30% of them are successful, but the neurological recovery remains very poor, around 6%. We know that the hypoxic ischemic brain injury is responsible for this increased mortality and prolonged disability, and that the cerebral metabolic rate for oxygen is reduced by about 6% for each 1 Celsius degree reduction in the patient's core temperature. So the whole process of cooling down the patients to 33 degrees is there to try to prevent secondary brain damage. Literature suggests that a delay in reaching the target temperature may even worsen the neurology in in-hospital circumstances. So we would like to know that if we start early temperature management in the pre-hospital phase, could that be potentially neuroprotective for patients compared to starting it later? In order to find this out, we can investigate the impact of pre-hospital targeted temperature management on neurological outcome. Our clinical question is, does earlier or pre-hospital targeted temperature management improve neurological outcome compared to later or in-hospital targeted temperature management in out-of-hospital cardiac arrest patients? Our population will be patients after out-of-hospital cardiac arrest, and we would like to compare the targeted temperature management started pre-hospitally versus the process started only in hospital. Our primary outcome will be neurological functions, and our secondary outcome will be survival to discharge, 90-day mortality, recurrent arrest, body temperature on hospital admission, time to reach target temperature, and adverse events. Our hypothesis is that reaching the target temperature sooner improves overall neurological outcome. On the slide, you can see our systematic search key, which consists of 3 domains. The first one referring to the process, the second one for the patients, and the third one to the study type, which is only RCTs in our case. You can also see the number of hits that we got in each database. After the selection, we have 8 eligible full text to work with. 7 of them are RCTs, and the 8th one is a follow-up of an included RCT. We are done with the data extraction. We have figures, and the next step will be to calculate the risk of bias. Let's see the figures. First, I would like to show the time to reach target temperature. We compared between the 2 groups of patients who were started to be cooled earlier versus later. This is very important because it shows whether if it's worth starting the procedure sooner, can it really help the patients to reach the target temperature sooner. We have 4 RCTs reporting data on this matter, about 1,600 patients. Their average time is given in mean and in minutes. And when we pull the difference together in the 2 groups, you can see it's minus 88.57 minutes, which means that people who were started to be cooled earlier reached their target temperature 88 minutes sooner than those people who were only started to be cooled later. Of course, this is both mathematically and clinically significant, because it proves a very strong base for our hypothesis, and then we can compare the neurological outcome of these 2 groups. Let's see the comparison of the neurology. This is our Primary outcome, most important figure, because the whole process of cooling down the patients is there to increase the number of people who leave the hospital with favorable neurology. We have 7 RCTs reporting data on this of about 3,300 people. The data is given in event rate. The event is, of course, having favorable neurology, and the end result in odds ratio. If we pull the results together, the odds ratio is 0.98, which means that we could not detect a measurable clinical difference between the neurological outcome when it came to patients who were cooled down earlier versus later. Resuscitated patients are very heterogeneous. And one aspect of being heterogeneous is their initial rhythm when they're first examined during resuscitation. It can be either shockable rhythm, like a ventricular fibrillation, or it can be non-shockable rhythm, like an asystolia or pulsus electrical activity. We did a subgroup analysis on this because people with shockable initial rhythm are known to have a little bit better odds for resuscitation outcome than people with non-shockable initial rhythm. We have 4 and then 2 studies presenting about this topic. And if we see at the pooled odds ratio, they're actually the same, 1.06 in both groups, which means that we also couldn't find any measurable difference between the 2 groups. Let's see, last but not least, a plot about the safety of the procedure. I'd like to show you the rate of recurrent or new cardiac arrests in the 2 groups. We have 5 RCTs reporting data. It's about 2,600 people. And it's given in event rate. The event means the new cardiac arrests. And when we pull the data together, the odds ratio is 1.33, which means that people who were called earlier had a 33% more chance to develop a new cardiac arrest than those people who were only called later. Of course, this is both mathematically and clinically significant. So we can conclude that pre-hospital or early targeted temperature management not only didn't result in a measurable clinical difference between the neurology of patients, but it can also be dangerous because of the elevated rate of cardiac arrests. Of course, this means that this process should not be given as a routine treatment for these patients, but there's still room for further research based on subgroups. Let me move on to my second project, which is investigating the efficacy and safety of seizure prevention on neurological outcome in cardiac arrest patients. After cardiac arrest, a large variety of rhythmic and periodic patterns, or RPPs, can develop in resuscitated patients. And it's very easy to miss them. In one third of cases, these are missed, especially if we're not using an EEG. We know that the cortical synaptic activity is very sensitive to this hypoxemia and ischemia, and it leads to post-anostic status myoclonus. These seizures may even appear days after the cardiac arrest, and while one single episode might not be an indicator of neurology, but if they're repeated or if they're ongoing, they can be ongoing for like 30 minutes. The fatality rate can be increased up to 100%. So we'd like to know that if we prevent these seizures from even happening, can that be neuroprotective for patients? In order to find this out, we can investigate the impact of seizure prevention on cardiac arrest patients. Our clinical question would be, does seizure prevention improve neurological outcome and reduce post-resuscitation complications in cardiac arrest patients? Our population will be patients after cardiac arrest without a seizure. Intervention will be seizure prevention therapy. The comparator will be standard care. The primary outcome will be neurological functions. And the secondary outcome will be survival to discharge, 90-day mortality, incidence of seizures, and adverse events. Our hypothesis is that seizure prevention improves overall neurological outcome. The clinical implication will be that with better neurological outcome, fewer patients will need round-the-clock care their quality of life improves, which will lead to personal, financial, and economical benefits. To summarize, we have 2 projects. The first one should end in September this year, and the next one, the spring of 2026. I'd like to close my presentation with an English idiom: where there's a will, there's a way. Thank you very much for your attention.
I had a question. What methods were used to cool down the patients in the first?
Thank you for your question. In the articles that I read and analyzed, there were a few ways to cool down the patients. Most articles used a large volume of IV saline that was cooled down to 4 degrees. And other articles used trans-evaporative nasal device, which cools down the oxygen as it goes into the patient's airway. This was the 2 main.
My question is about your first project. The earlier meaning was the same in the different studies, or did they mention it?
Can you repeat that question?
So the earlier intervention was the same in the different studies? I mean, the same 1 hour or 2 hours? Or
well, earlier in this case means that the procedure was done pre-hospitally. So the ambulance, the emergency medical service started this. So when the patient collapses, there are people who find them, make a phone call, and the ambulance arrives, and they start the procedure right then. And later, the in-hospital group means that they were only started to be cooled once they got into the ICU.
Regarding favorable neurology, what does that mean? Is it a standard battery of tests? Is it a repeated measure?
Yes, the articles use a couple ways to define favorable neurology. One of them is the cerebral performance category scale. It's a scale from 1 to 5. 1 means that the patient has no or minor disabilities, and 5 means that the patient is brain dead. And categories 1 or 2 are considered good outcome in the literature, and it means that the patient is able to lead an independent life. They might have minor disabilities, but they can dress themselves, they can talk, they can get around with public transportation, they can take care of themselves, so they don't need a round-the-clock assistant for them. This is what favorable neurology means. Some articles didn't use a scale, but only said favorable neurology, and this was their definition for that too, being able to lead an independent life.
So it's actually also a quality of life measure, right?
Yes, basically, yes.
Thank you.
My question is regarding the methods that we can use. So is there any difference between their effectiveness, and do we have a gold standard to do this pre-hospital temperature cooling?
No, there is no gold standard method, because right now it's not in the guidelines to do this, so there is no gold standard to do this procedure. And about the effectiveness, well, all of them works. All patients who were cooled down either way reached the target temperature significantly sooner than those who weren't. And also another outcome that we had is how cold they are when they're admitted to the hospital. And however they were cooled down, they were significantly colder on hospital admission than those who were not cooled. So they all work and do the job.
Regarding the first topic, so really interesting, and regarding the intervention of the targeted temperature control. So what have you found in the literature among the published data? How high was the temperature of the patient in the pre-hospital period?
Well, you mean when they were first examined?
Yes. So I'm just wondering about the relevance of this intervention. Just to control the temperature during the prehospital period?
When they were selecting the patients to compare, they didn't have a significant difference between their body temperature, of course, because then they couldn't be compared. They were all about 35.5, a little bit under 36, because of course, laying down on the ground. But after that, when they were started to be cooled, as I said, their body temperature was already significantly different when they were admitted, and then they reached the target temperature significantly sooner. And this is the base of our study, that because they reach it statistically sooner, statistically importantly sooner, then we can examine the neurology between the two groups. Because if they didn't reach it, then there would be no comparison between the two groups. So this is the significance of doing it earlier.
Okay. The second question regarding to this topic is this intervention takes a period of time. Okay. So do you have any data in your knowledge? How long does it take, and how is the impact on the outcome of the patient applying this intervention?
Well, what kind of impact are you curious
on the outcome,
about?
because it takes time. So it's a huge difference that you resuscitate the patient, there is a risk, and transfer the patient as quick as possible to the hospital, or starting with an intervention. I mean, you mentioned cooling down. Okay, so just administering any temperature control, which is take times and makes or takes the transfer time significantly longer, in my opinion. So.
The transfer time was not significantly longer in those patients who were cooled down. In the hospital, they both groups were continued to be cooled for 24 hours. And then they will slowly reformed, if that's what you're asking. But when their neurology was assessed, it was assessed at survival. I mean, it was discharge, sorry, and then 30 or 90 days, and it didn't show any clinical difference between the two groups.
Mm-hmm. Okay, and the third question, okay, last one. Really, so what about the patient? So regarding the patient selection, what about the patient under continuous mechanical chest compression? I mean, for example, applied by Lucas. So these patients are very involved into this analysis, or?
Yes, they were involved because some studies actually started the intervention after they reached ROSC, but some studies started the intervention intra-arrest, so while they were actively doing the chest compressions. And it's a great material for a subgroup analysis.